So the derivative of a parametric relationship is the derivative of y with respect to t over the derivative of x with respect to t, or whatever variables you're using. So in shorter hand, that's y prime over x prime, but you just have to remember that's with respect to t. So we usually put that function notation to emphasize the fact that we're not taking a derivative with respect to x in this case. So x prime is just the derivative of secant with respect to t, so that's 2 secant t tangent t. And the derivative of y is, so that's the derivative of 2 tangent t, so the derivative of tangent is secant squared. So if we plug that into our derivative formula, we get 2 secant squared t over 2 secant t tangent t. And you got secant squared over secant, so that's going to cancel out. Oops. And then if you want to simplify this, well, 2 divided by 2 just makes 1, so that's gone too. So you got secant over tangent. You could put it in terms of sine and cosine. I guess that's probably the most straightforward way to handle this. This top part, secant, is 1 over cosine. And we're dividing that by what tangent is. Tangent is sine over cosine. And notice how I rewrote it because I didn't want to have triple stack or fraction. So I got this secant is here, and that's being divided by tangent, which is here. And when I divide two fractions, I flip and multiply. The second fraction. These cancel, so it leaves you 1 over sine, which is cosecant. So determine the slope of the tangent line. It's at t equals pi over 4. So I'm supposed to analyze when cosecant pi over 4 here. So cosecant pi over 4, that's 1. You could first analyze what 1 over sine pi over 4 is if you don't know what the cosecants are, right? Just putting it back in terms of its reciprocal. And sine pi over 4, that's a 45-degree angle, right? And what we usually want to memorize is the special triangles, is the 45-45 triangle, where everything except for the two sides other than the hypotenuse have square root of 2 over 2 as their measurements. So the opposite divided by the hypotenuse is square root of 2 over 2. And so this is square root of 2 over 2. So that's 1 divided by the square root of 2 over 2. So that makes 2 over the square root of 2 when you flip and multiply. So the slope is 2 over the square root of 2. So determine the slope, we got the slope here. And then to find the equation of the tangent line, 2 over the square root of 2. So my slope is 2 over the square root of 2. And then to find the equation of the tangent line, we want y equals mx plus b, right? Because the tangent line, it's a straight line. We just need to know what the y-intercept is. So to find that y-intercept, we need an x and a y value. You can get those really quickly because it's at pi over 4. So you could plug that in for x and for y. Sorry, plug that in for t in the x and y equation. So plugging in pi over 4 over here. And then we got y of pi over 4 that equals 2 tangent pi over 4. So this is a value that sometimes students memorize in like a pre-calc course. This is going to be 1. I can show you why though in just a second here. So let's start with this one, 2 secant pi over 4. That's 2 over cosine pi over 4, because secant is the reciprocal of cosine. And so cosine, we can just draw that same triangle that we had before, a pi over 4 angle. means that we have square root of 2 over 2 for our sides. And cosine is the adjacent of this angle here. So it's the adjacent divided by the hypotenuse. So cosine square root of 2 over 2. So this is 2 divided by cosine pi over 4. This is 2 divided by 2 square root of 2 over 2. So we can flip and multiply. So we get 4 over the square root of 2. That's what we have just for our x coordinate, okay? At pi over 4, x is 4 over the square root of 2. And for the y coordinate, tangent pi over 4, that's going to be 1, and I can show you why, because tangent is sine pi over 4, tangent pi over 4 is sine pi over 4 over cosine pi over 4. Right, this is this. So we already saw that sine pi over 4 was square root of 2 over 2. Cosine pi over 4 is square root of 2 over 2, so it's the same thing divided by itself. So this makes 1, and 2 times 1 gives us 2 here. So we have our x and y coordinates, and now we can plug that into this equation to finally help us get the tangent line. Just a bunch of messy trig going on, right? But the big point is when you make a tangent line, you just need the slope, which you can find with calculus, and then you just need to plug in the x and y coordinates. Okay, so if you plug in 2 for y, and 4 over the square root of 2 for x, and simplify, that's 8 over 2, so that's 4, so it looks like b is going to be negative 2, right? Subtract 4 from both sides. So we've got our equation. Y equals 2 over the square root of 2x subtracted by 2. When we solve this equation, that's, 2 equals 4 plus b, subtract 4 from both sides. So there's the equation of the tangent line. I just checked with the answer key, and I missed something. I could simplify this, right? When you rationalize the denominator, you can multiply the top and the bottom by square root of 2 over 2. Okay, so check out, here, let me do that in longer steps. So we got this for a slope, 2 over the square root of 2, and that's right, that's the slope, but there's a better way to write that. You can multiply the top of the fraction and the bottom of the fraction by square root of 2 to get rid of the radical in the denominator. And when you do that, the square root of 2 times square root of 2 makes 2. And as you divide 2 by 2, that just makes 1. So square root of 2 is a much cleaner way of writing that. This should just be square root of 2 here. It's the same thing, but properly I should have rationalized the denominator.